Hello and welcome back. Today we're going to use the law of sines to find angles and sides. Now let's think back to geometry when you found congruent triangles. Now we know that there's 5 ways to prove that triangles are congruent, and that's side, 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 angle, side, angle, side, angle, 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 side, and our HL, hypotenuse leg. So if we're given any of these values, we can find the angles and sides for any triangle. So any oblique triangle, not a right triangle. So with traditional trigonometry, we could find those values. If it's a right triangle, now we're actually going to expand that to cover all triangles. So the law of sines is actually proportion, and it comes from using this altitude, the height. Okay, so what I'm going to do is actually consider looking at each of these angles. So whether the triangle, this angle A is acute or obtuse, if we're going to find the sine of A, well, that would just be H over B, looking at this triangle right here, right? And if we're going to find the sine of B, which I'm going to draw over here, well, that would be H over A, opposite over hypotenuse. Well, we can solve for H and say H equals B times sine of A, and H equals A sine of B. And using the transitive property, we could set those equal to each other. So B times sine of A will equal A times sine of B. And so if we divide both sides by A and divide both sides by B, we'll have the proportion sine of A over A equals sine of B over B. And we can continue that again to find the ratio for C. It's the same sine of C over C. So we have a proportionality here, a statement of proportionality, and it could be written the other way too. We can actually write it A over sine of A equals B over sine of B equals C over sine of C. Okay, let's start using the law of sines. We're going to solve for the given triangle, meaning we're going to find all the angles and sides that are missing. So we know that angle A and B are given, so that's 30 and 45, and we're given side A, which is 32. So that's going to be an angle, angle, side. So we know that we can prove triangles with angle, angle, side. The things that we're missing, well, angle C. Angle C is easy to figure out, just 180 minus 30 minus 45. That's 105. And then we're missing sides B and C. To solve for side B, I'm just going to set up the ratio. So sine of A, which is 30, over A, which is 32, equals sine of B, which is 45, over B. And we can simplify this, and that's why we're going to write our answers in exact form, because these are special triangles. So sine of 30 is just 1/2. Sine of 45 is root 2 over 2. So we know that 1/2 times B, if we cross multiply, would equal 16 root 2, and B would just be 32 root 2. And put that over here. And that's going to be in feet. Now let's solve for side C. So we know that the angle of side C, side would be at 105. We figured that out. So I'm just going to use a different color so we can see it clearly. So I'm still going to use A. So sine of A over A would equal sine of 105 over C. So again, this was 1/2 over 32. And this will be sine of 105. We know we can figure that out over C. So to figure this out, we're going to cross multiply. So we get C equals, I'm just going to write this here, C equals 64 times sine of 105. Now we could use the sums, the sign of the sum. So we could actually separate this into 60 and 45. And we could rewrite this as sine of 60 cosine of 45 plus sine of 45 cosine of 60. And when we simplify that, well, we know that sine of 60, well, that's root 3 over 2. Cosine 45, just root 2 over 2. Sine of 45, again, root 2 over 2. And cosine of 60 is just 1/2. So we could rewrite this as 64 times root 6 over 2, but that's plus root 2 over 2. And so that simplifies into 34, or 32, I should say, times root 6 plus root 2. So we're going to have a little bit of radical here, but that's okay. So C would be 32. I'm going to write this over here, 32 times root 6 plus root 2 feet. Okay, so more often than not, we're going to be using the law of sines with word problems. So here we have a tree that is growing towards the sun. So I'll put a tree here. So it's leaning towards the sun. This is a big lean here, but we're saying that this tree, and I'm going to use a different color here, is leaning at a 6 degree from the vertical, and you would usually have the sun up here. So plants do grow towards the sun here. There you go. And we have another data point. So from here, a point that's 30 meters away from the tree, the angle of elevation, this angle would be 22.5. So probably the hardest part is just to make sure you have the right picture. Now, considering we have some of the angles, we need some more angles. You can tell with law of sines, there's a lot of angles. So finding all 3 angles isn't too bad. We actually know that this is going to be a complementary angle, right? 2 complementary angles. So we just subtract 6 from 90. So this angle right here must be 84. And then looking at the top, well, that's just going to be 180 minus 84 minus 22.5. And so that's 73.5. Now, if we're going to find the height of the tree, put H right here, well, we need to use the angle opposite. And if we're given only this side, we're going to have to use the 73.5 to set it up. So since I'm solving for H, I'm going to use the law of proportions and reverse it. So we have H over that sine of that opposite angle will equal 30 over sine of 73.5. And then we just have to solve for H. So that means we just multiply both sides by sine of 22.5 and divide by sine of 73.5. And we could put that in our calculator. And that'd be approximately 11.974 meters. Now let's consider the ambiguous case. And that is when we have two sides and a non-included angle. So there are potentially 3 scenarios. We could have none, 1, or 2 triangles. So it's really important to consider what the other angles will be. So if we're given an angle, E is acute. That's 27. And the opposite side is 3.2, and its adjacent side is 4.1. Well, we're going to consider the height and compare it to the values for the sides of E and F. So the height is always going to equal, because we're considering what F is right here. So the height is always going to equal the adjacent side times the sine of that other angle, 27. So we know that the H is approximately 1.86. And we notice that 1.86 is less than the opposite side, which is less than the adjacent. So when H is less than the opposite side and less than the adjacent, we know that we're going to have 2 triangles. Because what potentially can happen is that we can have this opposite side swivel out, and F will be acute, or it can swivel in, and F could be obtuse. So this is when we're going to have two different triangles. And you can see them right down here, case 1 and case 2, how they're drawn. So let's first figure out what's going to be the measure for F when it's acute. So to find the measure for angle F, we just use the law of sines. So we know that sine of 27, that's E, over 3.2 would equal sine of F over 4.1. And I'm going to put this as F1 because this is our first case. So we know that F will be the inverse of sine. You have to take the inverse after you multiply 4.1 times sine of 27 over 3.2. So the first angle will be about 35.57. And so if this is 35.57, we can easily find angle G. Angle G will just be 180 minus those angles. So G would be about, I'll just put 180 minus 35.57 minus the 27. So G would be about 117.43. And then we could find side G, because that's the only side that we're missing, using law of sine. So we could set that up. So we have G over sine of 117.43 equals, and we could use that either one. We could use F or E. So I'll just use E, 3.2 over sine of 27. So I'll put side G is about, that'll be 6.26. Now what happens is that when we consider the two triangles, well, we have to kind of go back to the unit circle. We know that if we have a sine value in the first quadrant, and say this is pi over 6, well, that's 1/2. Well, the sine is also equal to 1/2 in the second quadrant, if this was 5 pi over 6. So remember, this is 180 or pi. So if we want to find this other angle, or this possible angle for F, we just subtract it from 180. These two are linear pairs. So this angle right here will be 35.57. But the second angle for F would be 180 minus 35.57, which we figured out over here from case 1. So that's just going to equal, if I can find this one, it's 144.43. All right, and then if we want to find angle G, you could tell it's really tiny. The second angle for G would just be 180 minus 144.43. There they go, make some room. Minus 27. So my second angle for G would be 8.57 degrees. Or we have to use that new obtuse angle there. So it can be acute or obtuse. And then to find the side for G, you're going to use the same ratio, but remember now we have a different angle for G. So when we set that up, it would be G over sine of 8.57 equals 3.2 over sine of 27. All right, so we're still just using E as our constant point there. And then just to solve for that, we know that G, the second G value, would be about 1.05. So if you notice, we have two different cases, and to find that second case, we're going to use that angle F and find its supplement. And then from there, we can find the new angle for G and the different side for the second case. Okay, let's consider more cases with SSA. So we're given the triangle ABC has sides 4 and 14. 14 for B. And our A equals 4. And our angle A is acute, that's 60. So if we set that up, so we have sine of 60 over 4 equals sine of b over 14, we'll get sine of b equals about 3.03. Now this should give red flags because we know that sine cannot be greater than 1. So when you put that in your calculator, you're going to get an error message. So this is not going to be possible. So when it's not possible, we know that there can be no triangle. Okay, that's probably the easiest and fastest way to decide if there are no triangles, one triangle, or two triangles. Again, you can also compare the height. So if we wanted to compare the height, remember the height is always going to be the adjacent side times the sine of the angle. So I'll just put this is about 12.12. And here we're given that the height is greater than A. So if this height is greater than A, then we know that this side right here, just going to redraw it, is going to just never connect, right? So here's the height, that's 16. This would be 4, and so obviously you can't have a triangle. So that's not going to work. All right, let's look at the second one. So for this triangle, we're given that the sides are 4.5 and 5. And again, this angle here is 58. So the adjacent side is 5. The opposite side is 4.5. So when we figure out the h, the adjacent side times sine of 58, and that's about 4.24. And so we know that 4.24 is less than 4.5, which is less than 5. So that's at HAB. And this is when you'd have two cases. If we're going to have two triangles, well, we can go ahead and figure those out. So pause the video, and then we'll go over those answers. All right, so let's compare our answers. So we knew that there was going to be two triangles here. And so when we use the law of sines for triangle 1, well, we can figure out that this angle here is 70.4 for B. So this is our B, our A, and our C. And so remember to subtract B and A from 180 to find the measure for C. And then you're going to have to set up another law of sines to find the side C. Now for the second triangle, let's draw it like this here. Remember, that's going to be cute. We know that this angle here is the 70.4. So if we're going to find the actual angle for B, we would subtract that from 180, which is 109.6. And if we're going to find angle C, well, you subtract 109.6 and 58, remember that was given over here, from 180, so our angle C is 12.4, and then we just have to use another law of sines to find that last side for C. All right, for this last problem, just for practice with the ambiguous case, we're looking at triangle ABC again, and we're given that angle A is 31, we're given that B is 5, again, not drawn to scale, and A is 12. So we're given actually that angle, the side A is greater than B. So 12 is greater than 5. And I'm just going to go back up to this chart so you can see. So when side A, you don't need this one right here. Let me just erase that. So when side A is equal to or greater than B, we're only going to have one triangle. So we really only have to be worried with 2 when B is less than A. All right, so if there's only one triangle, I don't need to compare the height or anything. So I'm just going to solve for the missing values. So we know that we have to find B, C, and side C. So again, to find angle B, well, that's just, I could set up the proportion. So we have sine of 31 over 12 equals sine of B over 5. And then so B is just going to be the inverse of sine of 5 times sine of 31 over 12. And that's going to be approximately 12.39. Again, we're going to find angle C, subtracting those values from 180. So 180 minus 12.39 minus the value for A that we're given, So angle C will be equal to 136.61. And then we just have to set up another proportion to find C. So C over sine of 136.61 would be equal to 12 over sine of 31 using A. And we can find C will be about 16. Okay, we're going to move on to the area of a triangle. And so we know that the area of a triangle is just 1/2, I'll put area here because we have an A as well. So area equals 1/2 times the base times the height, right? And so if we're going to use any of these triangles, the base here, I'll just use that as C. Well, if we're going to find the height, well, we could find the height using trig. So if I'm going to identify this height here, so that would just be sine of, I could do sine of A equals h over b. So my h would be b times sine of A. So for the area, I could substitute the base as C, and the height was b sine A. And we can just reverse those or use the associative property and the commutative property. So this would be 1/2 BC sine of A. And you can see that right here. And we can do that for all the triangles, looking at different bases and comparing the heights. So if we're going to find the area of a triangular lot here with an angle in between, this is going to be 80. Well, we know that this side was 24 and this side was 54 feet. So you can notice right away that they're not in the same units. So I'm going to put them both in yards. So that would just be 18 yards. So to find the area, it would just be 1/2 24 times 18 times the sine of 80. And so that's going to be approximately 212.72 yards squared. Okay, so using the two sides and the included angle. Now let's consider a word problem and going back to bearings. So remember, for these, we want to make sure we draw a picture. But we have a child swimming, maybe they're in the junior lifeguard program at the beach. So we have this angle is going to be north 28 east. So that's 28 degrees. Remember, we're going north, south, east, west. So that's north 28 degrees. And this is, I'm going to label this point A. And they swim to point B. Maybe there's a buoy out there. And then they have to change their bearing to go to point C. And so this angle, I'm going to label this here, is north 58 degrees west. So that angle is 58. So if we know that that angle is 58, well, we also know that this angle right here would be 58 because of alternate interior angles. And then if we wanted to figure out this angle for B, well, that's just easy. We could use 28 here too. Or we could just subtract 58 and 28 from 180. So we know that this angle would be 94. So we're given that the distance from A to C is 800. So now we have our B and our angle B. And we want to figure out how far this child swam. So that's going to be the distance of C plus A. So first let's find A. So A is going to be over sine of 28, which will equal 800, which is B over sine of 94. So A is approximately 376.5. And then to find C, well, that's going to be over sine of 58. And we can set that ratio equal to 800 over sine of 94. So C is approximately 680.1. Good ocean swim. And so when we add those together, A plus C, that's going to be about 1,056.6 meters. All right, well, I hope this lesson was helpful, and I'll see you all in class.